Hello, I'm Lizardo Prieto, and in this video I will show you how to use the syntax analysis technique. Syntax analysis technique is used in test-driven development in order to create a lot of different tests for the input of the methods we want to develop. Let's see it with an example. Imagine we want to create a function in order to check for the validity of commands in a command prompt or shell, right? So we may define a function named shell processor, for instance. This function will get a simple parameter, a string, that is the command itself, and it may return an exception. In this case, given that we are defining a function probably inside a class, we can create a custom type of exception in order to handle all the errors regarding this new class. We may call this shell processor exception. Okay, here we have the definition of the function, right? And with the syntax analysis method, we're going to create all the different tests for command. Okay, so a valid command for this function may be copy name of a file A to B. Beware of the space. Another command that may be recognized by this function could be rename, for instance, A to B, right? Both are valid. So, the first step when using syntax analysis technique is to create a grammar, okay? A grammar that will assess all the different valid possibilities at the input, okay? In this case, the grammar has to be regular, type 2 or 3. We should try to avoid redundancy or recursion, okay? And also avoid lambda or empty productions. So, let's define our grammar. First of all, we should start by the non-terminal, the first production, that is the command itself, okay? And the command is made out of type of the command, then a space, right? Then the file name, then a separator composed by two spaces and the word to, and finally another file name, okay? This is equivalent to this other file name, so file name again, right? Let's continue deriving or defining our grammar, okay? What's next? Okay, type can be copy as terminal or rename. Perfect. Space is actually the space character, right? So empty. Then we have file name. That actually can be a letter. We are considering A or B, but okay, both are letters, right? Then separator is again a terminal production composed by space to space. And finally, letter in our case, in order to simplify, is just A or B, but it could be also C, D, and so on and so forth. Let's simply define it as A or B. Okay, great. So once we have our grammar, the next step is to create the derivation tree. And how can we do it? Okay, first, level 1 will be the root of the grammar. This will be the first node, and we must number all the nodes from top to bottom and from left to right. So first, okay? This will be useful later in order to apply, well, the traversing the tree, and also to check for equivalent nodes that may be affected by the same operations. So we don't need to repeat the tests we are creating. So once we have the command, next level, level 2, we have type, we have space, we have file name, in short, okay, separator, and again file name. So second, third, fourth, fifth, sixth. Okay, do you see? We are creating the derivation tree actually. Then level 3, in type, now we have terminals, right? We have copy and we have rename. In space, we have as well another terminal. In file name, we have a non-terminal that is letter. Separator, we have the terminal 2 with space before and after. And then we have again 6, as you can see, is equivalent to 4 letter. Great, let's continue numbering. 7, 8, 9, 10, 11, and 12. Perfect. And finally, at level 4, we have letter with A and B, and again A and B. 13, 14, 15, and 16. Okay, great. Now it's convenient to create this nice table with non-terminals and terminals. Here we start 1, 2, 3, 4, 5, 6, 10, and 12. And for the terminals we have 7, 8, copy and rename, 9, a blank or space, 11, 13, 14, 15, and 16. Great, so we have the table done. So what's next? Okay, now we have to create the valid test cases, right? And what's the strategy? Okay, once we have the complete derivation tree already created, we have to traverse it. How? We have to traverse it covering all the non-terminals and trying to find a configuration that minimizes the amount of possibilities that cover all the terminals, right? So let's start. From command we go to type and we choose copy, for instance. Now space, file name, letter, and let's choose A. Then separator 2, file name again, letter, and let's choose, for instance, B. Okay, look, we have 1, 2, 3, 4, 5, 6, then 7, 9, 10, 13, 11, 12. All the non-terminals are covered now, so we are doing it fine. And 16, right? So we have the first valid test case. We should test copy A to B. Great. But we need yet some cases to cover 8, 14, and 15, right? So let's do it again. We start from here. In this case we go for 8, again non-terminal and terminal, non-terminal, non-terminal, and let's go for 14 again, and finally letter A. So with this new configuration we are taking 8, 14, and 15, and this is renamed B to A. Great, we have the valid cases. Great, that's fine. But what comes next? How should we proceed? Okay, now we have to find the non-valid cases. Okay, In order to do so, we have to apply 3 different operations. For the non-terminals, 2 operations, and 1 for the terminals. In this case, for the non-terminals, subtraction and duplication. Okay, the idea behind is to remove the non-terminal or to duplicate the non-terminal. So let's see an example. Okay, the root node. Imagine we do the subtraction. What's the outcome? An empty string, right? Because we don't have any production. If we kill the root, we cannot create anything. So empty string, and that's not valid. Okay. Now let's see what happens if we duplicate the command. Then we can have something as an output like copy blah blah blah, copy blah blah blah, or copy blah blah blah, rename blah blah blah, and this is not valid. Okay, so we continue traversing the tree, top to bottom, left to right. So we reach type. What happens if we subtract type? We may face productions like blank A to B, and this is not okay. Definitely is not okay. If we duplicate, then we can have things like copy A to B, and that's not good also, right? Well, I think you get the point in the subtraction and duplication of nodes. This is for non-terminals, but now we have to apply as well operations for the terminals. Again, in this case, the only operation we have to do is modification. So, where here we have copy, for instance, in this terminal node 7, modification implies that we have to change the value. So we could use anything else like move. Move is not recognized by the grammar, so it's wrong. So we would have an operation like a command move A to B, and this is also not correct. What may happen here at node 9, that if we change this space, we can have things like copy. Imagine we use a hash symbol. So copy hash A to B. This is also non-valid. Do you get the point? Right. So think about something, okay? I told you we have this part is completely equivalent to this other part, okay? So once we create cases for this part, we don't need to repeat the process in this part, okay? And the same for copy and rename. They are both in the same level and both are terminals from type. So 7 is equivalent to 8. I mean, if we change the value for copy, we don't have to change it as well for rename. Okay, it's equivalent, so we don't need to repeat the process here as well. So eventually we will end with all the non-valid test cases. And once we have coded all the cases, all the possibilities for valid and non-valid in different tests, then we can start coding the proper function and start repeating the tests until all of them are working fine. So that's all. If you have any question or comment, please contact me at my email address is up there or via Telegram. Thank you for watching and see you soon.